Today we're taking a look at section 3.2 on truth tables for negation, conjunction, and disjunction. And we'll begin with the conjunction. It's the truth table for the conjunction P and Q. Okay, so let me see if I can come up with, let's let P be the statement, the pencil is yellow. And let me draw a couple of pencils here. Okay. And I want one that's yellow. Okay, and excuse my shading because it's going to be a little bit outside the line. Alright, here's pencil number 2. And this one I'll make blue. Okay, and now let's do Q. Okay, let me see if I can find a red. Okay, so there's flower number 1. And I need a second flower. Go here and find a... Well, this one isn't going to look much like a flower the way I've drawn it, so we'll call that the flower number 2. Okay, I'm going to call this pencil number 1, pencil number 2, flower number 1, and flower number 2. Okay, now why am I drawing all these pictures? Well, what I want is an illustration so you can think about the truth value when I make a statement. Okay, so here's my yellow pencil, here's my red flower. And what I'm going to say is that P is the statement, the pencil is yellow, and Q is the statement, the flower is red. Okay, so if I say the pencil is yellow and the flower is red, when I'm holding these two items, have I made a true statement or a false statement? Pencil is yellow and the flower is red. I have made a true statement. Suppose I say the pencil is yellow, pointing at this one, and the flower is green, pointing at this one. So I've said a true statement in this part and a false statement here. So the pencil is yellow and the flower is green would be a false statement. The pencil is blue and the flower is red. Okay, so I'm still looking at these two items. The pencil is blue and the flower is red. I made a false statement and a true statement, and I end up with a false statement. Notice for it to be true, we have to have both of the individual P's and Q's to be true. And finally, if I hold these two objects, the yellow pencil and the red flower, and I say the pencil is blue and the flower is green, I've made two false statements, and my conjunction P and Q will also be false. So the only time the conjunction, and that's what we call this, the conjunction is true is when both of the component statements are true. Okay, now I'm going to use my same items that I drew up above. If I say that the pencil is yellow or the flower is red, and I'm still using the two items that I have here, and I'm holding them, and I say the pencil is yellow or the flower is red, I've made a true statement. If I say the pencil is yellow or the flower is green, again holding the same two, I've still made a true statement because the pencil is yellow. If I say the pencil is blue or the flower is red, I've made a true statement because one of those is true. If I say hold these same two items that I have circled and say the pencil is blue or the flower is green, I've made a false statement. So what we note is for the disjunction, that will always be true except in the case where both components are false. And that's the only time we have a false. Alright, now, here's why I drew two of each, and I actually only needed two for the first one. Okay, suppose I have a true statement saying the pencil, or the flower rather, the flower, I love the way that colored in there, the flower is red. The negation, if I negate the statement the flower is not red, would be false. Okay, if I start with a false statement like I have, if I say the flower is red, which it's not, it's green, the flower is red, then when I change to the negation and say the flower is not red, then it becomes a true. So negating a true becomes a false, and negating a false becomes a true. Now, in this section, we begin to construct truth tables. And what we have to do is we have to evaluate the truth value for each component statement, and then all of the parts that are negated or in parentheses and so forth. So one of the things we have to figure out is how many rows we need in the truth table. And the number of rows is dependent upon the number of component statements. If we have one statement like we had here with this table, we will have 2 rows. And you can see those are my 2 rows. If you have 2 component statements like we did here, then you're going to have 4 rows. Same is true up here. We had 4 rows in that truth table. All right. If we have 3 component statements, it grows to 8 rows. 4 component statements, it grows to 16. In general, it's going to be 2 to the n rows, where n is the number of component statements we're dealing with. So it's just like the formula for the number of subsets. Okay, so my next question is, how many rows would this statement require? So you want to look at the number of distinct variables and count those. That'll give you the number of component statements. So let's see, what do we have? 1, 2, 3, 4, 5, 6. So our formula is to take 2 to that power. So I believe that's 64. And no, I won't give you one where you have to work out 64s. 64 rows. Take too long to do it. Too big a piece of